Hello and welcome to today's workshop on double stars. Now they can be done a billion trillion different ways, but today we're going to use a way that introduces some astronomical tools that research scientists use, particularly Aladdin. And even though research scientists don't use it all that often, we'll use Excel because that's something that a student will be familiar with. Now with Aladdin, this is a good way to access all sorts of images and catalogs and all sorts of stuff. And once students have a basic idea of that, they can really leverage this tool to go explore deeply. But what we're going to do today is we're just going to split you up into groups. Pairs good because one of you could be measuring and the other one could be writing down what you're measuring. Basically, the simplest thing we can do is we can take the FITS files, which will be allocated, and you drag a FITS file into Aladdin, and that just brings the image in. And there's an image. I'm holding down my right mouse button and sliding around, and you can change the brightness and contrast. And you can see there's a bunch of stars. And zoom in and out with your mouse wheel, and you have to figure it out with the trackpad, but you can do it. I've done it, but I've forgotten. So we have an image of the stars, but we can also have the measurements of the stars. And these measurements have been done earlier, and we can drop them in. So what I've just dropped in is a text file. It's just a text file that has positions, right ascension, declination, x and y pixel location, and how bright it is, error in brightness, and then error in position. You don't need to know that. Kids don't need to know that. But it's good background for you, in particular as an instructor. And basically, by dragging in this catalog over the top of this image, we have the image and then we have the measurements. And Aladdin doesn't pick great symbols, but we can see that there are red measurements all around. Now, I haven't picked a double star to do, I just picked a random image that was handy on my computer. So imagine this is our double star. We have two measurements here. We have a measurement here. We click that. We can click it, or we can select it. It's pretty easier. Select and drag a box, or select and drag a box for both your measurements. And then you can see down here we have the contents of that file written out here. They're much more easier to read manner than trying to find the stars in that text file. So here you've got the position of RA and DEC. So you've got RA for one of the stars is 306.12 and then DEC is 16.76. And you see because they're close by each other, the difference really doesn't start until the third or fourth decimal place. And double stars are close. That's why they're of interest. Now, as you go through, you can you have multiple uh, catalogs of measurements, and you can just drag in another catalog. See, and you can turn them off and on with these sliders on the side. Now I've got the blue image, and we can measure out the stars here. Now there can be a lot of these catalogs, but I mean, really, just to take the measurements, just maybe do two or three. And what we're going to do with those measurements of RA and DEC is put them in this spreadsheet here. Now I'm going to do this quickly and not actually copy the numbers from Aladdin because that seems to be straightforward. I'm just going to make up some numbers so you can see how the spreadsheet functions. So here we have elements RA and DEC for star 1 and RA and DEC for star 2. And this is meant to be image number 1, image number 2, image number 3. So this will work all the way up to 50. But start off by doing 1, 2, or 3. So I'm going to make up a couple of stars and make up some measurement areas too. So 232.001. I'm just making this up, so don't judge. And then there's going to be a nearby star. Well, actually, we just make it a degree away. It doesn't matter at this moment. Oh no, we won't. 3. I'm just going to try and make something sensible. Okay. Just making up some numbers. Same with DEC. 22.1. So I just made up some random numbers, and I didn't make them as random in Dec as I could have. Usually they'd be off at some angle. So, but you can see here that we've got this our measurements here. So this dot here, blue, 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 those are 3 measurements plotted on the RA and Dec grid for star number 1. Star number 2, we have the same thing. We have our dots up here. And it's calculated the mean RA and Dec of each star and the standard deviation. So the stars are at the actual kind of colourful circles are at the mean position of the measurements. And error bars are the standard deviation. So you can see here I've put this unreasonably out there, and so we've got huge error bars. So this gives you an idea. As you add up your 50 stars into the image, you'll start getting more dots, and then you'll get these error bars that show you the standard deviation and position. And so over here, the spreadsheet will automatically calculate the position angle and the distance. Now you can see we've got one whopping outlier. Which one is that? That's probably this one to that one. So we've got the position angle going 80 degrees down that way. And the distance is like nearly 5-6 times longer than this distance here. Now that makes sense. That's a trick. It's just an artifact of me typing in silly values. So you can see, there you go. That's what it is. So this is position, angle, and declination. Distance are the 2 things that you want to measure in double stars. And as you go through, you can see, just like here, you can see that there might be an outlier ones. And if you go, oh, that's an outlier, I'm going to change that. Oh, I realized I typed something in wrong. I'll go 22.105. I forgot the there we go. Now look, makes a lot more sense. So you can see as your measurements are building up, you can actually see the effects and the position angles and the distance as time goes on. Remembering these values are just silly ones I just picked for this video. So that's the gist.